Hello, and welcome to the ADIAT version 2.0 launch spotlight and demo. I am incredibly excited to share this with you today. This is, without question, the biggest release we've had of ADIAT since it became public. So large, in fact, that we're actually going to split this into 3 videos. So the first video, we're going to focus on the improvements to the image analysis setup process. And the second video will spotlight some changes in the image viewer experience. And the third video will be all about the brand new streaming analysis capabilities in ADIAT. I promise we're going to be very light on theory in these videos. We're really just doing the demo of the tool itself. But before we jump over to the tool, I want to take a moment to say thank you to a few folks who made this possible. ADIAT is sponsored by Texas Search and Rescue, TXR, but it is an open source project, and to that end, there are individuals outside of TXR without whom ADIAT 2.0 would not be possible. So first and foremost, I wanted to say thank you to John O'Keefe from El Dorado SAR in California. If I stopped this video every time to point out an area where John contributed directly to the code, this would be a 2-hour video. There literally isn't a component of ADIAT 2.0 that he did not impact directly or indirectly in some way. So John, thank you very much for continuing to contribute to ADIAT and make this possible. I'd also like to thank a few folks from Italy's National Alpine and Cave Rescue Association. So Alessio, Severio, and Giorgio, thank you very much. Alessio contributed directly to the code base with one of the new features that we're going to be looking at. Giorgio provided some additional images from their organization, which we used to further train the AI person detector algorithm with those images in a new environment, providing new information that the algorithm needs to be able to function properly in alpine scenarios. And certainly Savaria as well for contributing features and providing input on new features as they're being built out. So to all of you, thank you very much. And to everyone else who provided feedback and ideas through email and other means, thank you very much for being a part of ADIAT and helping us get to where we are. With that, we're going to move over to the tool and start the demo. All right, I'm over in ADIAT now, and as you can see right from the get-go, this is a new landing page. So as I mentioned at the top, in addition to ADIAT's image analysis capabilities, we've now added streaming analysis as well. So the first decision you make when you come into ADIAT now is, are you interested in doing streaming analysis or image analysis? As I said, for this first video, we're going to focus on image analysis, so I will go ahead and click on images. And that will take you into the ADIAT image analysis guide, which is our wizard approach to setting up image analysis. So we've tried to be very conscientious in ADIAT version 2.0 of introducing new capabilities that make the tool even stronger, while also making it more approachable to new users. So I know when a lot of folks are coming to ADIAT for the first time, it's probably in the context of being in a search or possibly starting a search, and I don't want the tool to be so complex and so hard to learn that they spend all this time just ramping up on the tool instead of actually utilizing it when they need it for some sort of search operation. So we've made the tool more powerful, we've added new capabilities, but we've also added this guided path approach so that new users can come in knowing nothing about the tool, knowing probably a little less about image analysis and computer vision and some of the underlying themes of ADIAT, and still be able to use the tool and use it effectively for image analysis and streaming analysis. So once you click on images, the first thing that pops up is this screen. Now, I should say off the bat, if you want to skip the wizard, you always can do that. You can check this box. You'll never see the wizard again. Click closed, and that will take you to the main analysis window that you're probably used to seeing as an ADIAT user. But for now, we're going to go through the wizard. So the first question we ask, what would you like to do? So are you actually starting new image analysis, or are we just reviewing existing image analysis? So if you're just coming back into the tool to review image analysis that has already been run, we can go ahead and click on Review Existing Image Analysis. For our purposes for this demo, we're actually going to start a new image analysis process. We'll go ahead and click on that button. And then it takes us to our input and output directory selections. So the functionality here is the same as it's always been in ADIAT. Your input directory is where the images are that you've taken, the raw images. And the output folder is where we're going to store the detection information once we finish the analysis process. So again, we're trying to make this a little more approachable, so it's not just input output, it's where are the images you want to analyze. So we'll go into that. I'll select my input directory. Second question, where do you want ADIAT to store the output files? And I'll go ahead and say output. And we can go ahead and continue on to the next step. So in addition to making this more of a wizard in kind of a question and answer format, we're also trying to automate some of the information collection. So in this case, what we did is we looked at that image input directory, took the first image, and then pulled the meta information to see what type of drone or camera was used and what the above ground level altitude was that the drone was flying. And this comes into play a little later in the setup process where we start asking questions, trying to discern what size object the user is looking for. So in this case, it correctly detected. I was using an Air 2S, and we're flying at 150 feet AGL. And it does provide the estimated ground sampling distance at that point based, again, on camera characteristics, the altitude, all those sorts of things. Continuing on, this is where we get to, okay, what is it that you're trying to find? And what we're trying to do here and with the previous question is get to what are the min and max object sizes that we're supposed to be looking for. So we specify, in this case, what it is we're looking for in the context of everyday objects. Is it a small article like a hat, a helmet, a plastic bag? Is it something the size of a day pack? Is it something the size of a large pack or a person standing up? Is it the size of a person lying down? Those sorts of questions. Again, trying to make it approachable to someone who's not, well versed in ground sampling distances and pixels and resolutions and all those things. So we just ask, what is it you're looking for? So I'll go ahead and leave this with the defaults for now. We're looking for something between 1 square foot and 6 square feet in size. And by the way, if you are not in the US and use the metric system, if you set your preferences to meters instead of feet, these will all be in units you are accustomed to. Next comes our algorithm selection process. So as you may remember from version 1.6 of ADIAT, we introduced a algorithm selection guide, which was kind of a decision tree to help you decide which algorithm makes the most sense for your current situation. This is just the programmatic equivalent of that. So a lot of the questions are the exact same, and it just walks you through that tree process. So in our case, are we using thermal images? I'll go ahead and say no. Do we specifically want to detect people? I'll go ahead and say no to that as well. Are we trying to find a specific color? Okay, I'll go ahead and say yes to that. Do we want to manually adjust the color range? I'll go ahead and say yes. And finally, do our images include shadows or areas of uneven lighting? And I'll go ahead and say no. And that points to which algorithm I should use. And as you imagine, if we go back and we choose different answers, it will recommend a different algorithm. So let's go back. Are we looking for thermal? No. Are we specifically detecting people? No. Are we trying to find a specific color? Yes. Do we want to manually set the range? Yes. Do we have shadows in areas of uneven lighting? No. That gets us to the RGB color range, and we click continue. In this next screen, the questions asked or parameters that we provide are going to be specific to the algorithm that was selected. And this is actually a great opportunity to introduce a new concept for all of our color-specific finders. So 2 things we've added here. 1, instead of just adding a color from a color picker, There are now multiple options for how we can add colors for the algorithm to go look for. We can still go to our color picker. This is RGB, so it's our standard RGB color picker. We can pick from an image. We'll look at that in a moment. We can pick from a list of common colors. So let's say we're looking for dark denim, or we can pick from any recently used colors that we've used on this or other searches. You'll notice in this guided experience, we don't ask the user to provide the ranges themselves. We just ask them to provide a match tolerance. How wide or narrow, relatively speaking, do they want the range to be? So not only, as you can see here, not only do we have multiple mechanisms for adding colors, we can now support multiple colors at the same time, or multiple color ranges. So if you're looking for a subject who was carrying a blue backpack and wearing a red helmet, we could search for both of those color ranges at the same time, or in this case, 2 different shades of blue and red as well. If we go up to view range, we'll see it selects everything that is within all of those ranges. And when the algorithm runs, it will run against all those ranges at the same time. It's not like it's running it all through with one and then the next and the next all at once. If it matches any of the ranges defined, it will be flagged as it was before. Continuing on from here, we have our general settings. So what color should be used to highlight the areas of interest? We can select that color. How many images should be processed at the same time? This gets down to computer performance characteristics. We have an option here to run a benchmark. It'll detect how many CPU cores your computer has and recommend a number of processes based on that. We can also decide whether or not we want to process to essentially downsample the image and process at a lower resolution. We lose some of the detail, but the flip side is we can run faster if we decide to downsample. This really comes into play with some of these super high resolution images, the 48 megapixel plus sorts of images where it takes a little bit longer to run at full resolution. Maybe in the interest of time, you reduce that down to 75 or 50% if you're okay losing a little bit of the fidelity in the image in the interest of being able to run the analysis faster. And finally, our last question, were the images captured in different lighting conditions? So this, if you're familiar with the ADIAT interface in previous versions, this leads into histogram normalization. Once those are set, you go ahead and hit start processing, and that will take you over to the main image analysis window and start the processing. I'm actually going to go back just so we can look at what some of the other question sets are for some of the other algorithms. So we'll still say we're not doing thermal image analysis, but let's say we are specifically wanting to detect people. And then, of course, it tells us we should use the AI person detector algorithm. We hit continue. And now you see, rather than setting parameters, it just asks simple questions of, hey, how confident should ADIAT be before marking something as a person? And this is a common theme in a lot of these algorithm selection or setup processes. It's really a question of how aggressive do you want the algorithm to be, balancing false positives versus false negatives. So if we want it to be, in this case of the AI person detector, very confident, that means only things that it's super confident are people will be flagged. Whereas if we're very permissive, we're less likely to miss a person, but we're going to have to wade through a lot more false positives of things that really aren't people, but things are. Go ahead and go back, reset again. Still not using thermal. Let's say no to detecting people. Let's say no to finding a specific color. Now let's do your images contain complex backgrounds or structures. So let's go ahead and say yes, and that leads us to we should be using the MR map algorithm. So if we click continue here, now we have 2 questions. 1, do your images contain complex scenes with buildings, vehicles, or mixed man-made ground cover? This teases out whether or not we should do image segmentation. And then again, as I said, kind of that same theme, how aggressive should the algorithm be with detecting anomalies? Let's go ahead and let's just pretend we're doing thermal for a second. Are we looking for a specific temperature range? No. Then it says use temperature anomaly. Again, same sorts of questions. Do we have complex scenes? Are we looking for things that are warmer than surroundings, cooler than surroundings, or both? And how aggressive should we be? So again, that common theme of how aggressive should the algorithm be for a lot of these that are scoring based. So let's go back and set up, our color range finder for RGB. So I'll say, all right, I'm just going to use a recent color, and we will use this one. I'm going to say I want it to be fairly wide just so we get more matches. So again, match tolerance, same sort of thing as aggressiveness, very narrow, narrow, moderate, wide, very wide. Continue, these are already set for me, and I hit start processing, and then up pops the image analysis window that you're probably used to seeing if you've been in ADIAT before. And we let that run. It completes just as it has before, and then we would continue on to the image viewer, which we're going to look at in the second video. But for now, I'm going to stay here so we can look at some of the other enhancements to the main image window. So up at the top, we have our menu. This has been extended. We can always get back to the image analysis wizard here, even if we've said no, skip it. Whenever we come in, we can get to it this way if we want to change our mind and actually go through that wizard process instead. We can swap over to the streaming detection system if we want to move to video streaming instead. We can load results files from here. We can load the application preferences and set those. And we still have our video parser if we want to take video files and take frames from those to use for image analysis. As you see, when it came in, it set our input and output folders for us. That process is the exact same as it always has been in ADIAT, though we will look at the output folder here in a minute. We are changing what we are storing in the output folder. We have our min and max object size. And by the way, you see as I mouse over these, we've also improved the tooltips for these as well, just again, to make it a little more user-friendly. You don't need to know what all these terms mean. We'll provide tooltips to kind of explain what we're asking for in these. You'll see it's kind of a crazy value here, 18,907. That's because that was derived from the answers to the wizard questions, specifically about the object size. Again, object size paired with ground sampling distance calculated from our drone and our altitude and our camera characteristics gets to a max object area. There's also some math in there to kind of expand that range a little bit just to provide a bit of a buffer. So that gets us to this value. We've added a no max limit checkbox just to make it a little easier. If we don't want to set a max object area for whatever reason, we have our object identifier color here, our max processes, and processing resolution that we looked at in the setup wizard. Finally, down here, we have histogram normalization. If we want to turn that on, we provide our reference image. If you do this through the wizard, it will just take the first image in the input folder and use that as the reference image. You may notice that we have removed a feature here, k-means clustering. K-means clustering, if you recall, was designed to basically take a complex image with 60 million colors or however many colors in the RGB space and distill that down to 36, 56, however many colors. So it basically greatly simplifies the colors that appear in the image. And it was extremely expensive from a resource standpoint. It took a long time to run. And frankly, it's in a lot of ways superseded by just using the MR-map algorithm, which gets to a similar result using a quantization process, which is much more efficient than k-means clustering. So we went ahead and removed that feature from ADIAT. It wasn't really being used, and it was just one more complication for users to understand. Below that box, we have our algorithm selection. We do have the same set of algorithms in ADIAT version 2.0 that we had in 1.6, though I will say virtually all of these have been modified and improved in one way or another, and we'll take a look at them one by one here in a second. And then down below, we have our Start, Cancel, and View Results button and our information window as analysis progresses, and you'll see we've added percentages and a few things to make it a little easier to understand what's going on and how far into the analysis process ADIAT is. In between, where I skipped here, are the algorithm-specific parameters. So we already kind of looked at this for color range. We have our add color dropdown where we have from the color picker, from an image. I'll go ahead and click on that one now. And what this does is it's similar to opening an image in MS Paint or whatever photo editor and using the eyedropper to pick up the color of a single pixel in that image. So I can go ahead and say load image. And open an image, and you'll see if I click on color selector here and click on the image somewhere, it'll pop up and say, okay, here's the RGB color. Do you want to use this color? If we mouse around, we'll see that it shows you the RGB value of wherever the cursor is at that point. So we'll go ahead and select a color through this mechanism, say use color, and then we'll add it here with our default range. So the range mechanism has been updated for color range as well. You'll remember in the setup wizard, we just asked the aggressiveness question essentially of how narrow or wide do we want that range to be. In the actual parameters here, we've decided to allow the user to set it for each individual parameter. It used to be it was just plus or minus for R, G, and B for each of the channels. Now we explicitly let the user set those. So in this case, for our first one, we have red from 0 to 75. We have green from 95 to 245. And you can see the original color here, by the way. And then blue from 180 to 255. If I want to change this color, I can go ahead and click on the color swatch here, and it brings up the color selector again. Down here, you'll see by default, it brings it in with a range of plus minus 50. So it's 52 for the red channel. So it's 2 to 102. And that's kind of the default across the board as we bring in colors from other sources. We have our gradient here representing the min to max color range. And then we have the range viewer again, where we can see in this case the color ranges happen to overlap, so it creates one window of color that it's going to be looking for. Moving on to the color range HSV. So again, we have our four options. We have from color picker, from image, from list, and recent colors. However, with HSV, we have a brand new HSV specific color picker. So HSV works a little differently than RGB in that the hue is represented by some mark essentially in a 360-degree circle, and the range is set as some arc component of that circle. So this line in the middle is the base color we're selecting, and the two dots on the two sides allow us to set the range. So basically, again, creating that arc portion of the circle that we are capturing, saying, hey, this is the hue range that I want to include. Over here on the left is where we set our saturation and value. So we can make this box bigger or smaller, or move it away from the 100% here. And then down below, you can see kind of what those values would be, what our range will be, what our saturation and value range will be as well. We can also use a slightly different color picker or image color picker in the HSV space. So if we click on this and browse and open our same image, we can see that we can control click. And not only do we select the color, we're actually setting the whole range here. So if we select multiple pixels, you'll see over here in the final range, it's expanding that as I include more and more colors. So again, instead of just selecting one pixel and setting channel values or HSV range values, we're automatically doing that by selecting multiple pixels. Now this is really useful. Both of these image color pickers are useful in situations where, for example, you're on site and you have an article of clothing that matches what the person was wearing. You can put that down, take a photo of it, use one of these two two tools to select that color range, and it takes a lot of the guesswork out of that. You're not having to discern lighting conditions and those sorts of things. You can just use the tools we provide in ADIAT to select the range for you, and again, take the guesswork out of that. So I'm going to leave it like this, say OK, and we can see the range that it selected. And then I'm just going to go ahead and expand that a little bit and click OK, and that will, you'll see it will bring it back into the viewer here. Excuse me, the setup window here. Let's go ahead and add another color. Let's say from the range. And let's do this just to show one little quirk that you may run into. So if you look at the units here, saturation and value are percentages. So as you would imagine, they go from 0 to 100. Hue, because it is a 360-degree circle, we need to be able to account for the fact that you can go over 0, just like, you know, going over 12 o'clock on the clock goes from 12 to 1 again. Same sort of thing here with the circle. So we can go from 339 to 360, which is 0, and then around to 31. So we're crossing over and going around the rest of the circle. So as long as you have that understanding in your mind and you picture this as a circle, this makes sense. Otherwise, it's probably a little confusing. How the heck do we get from 339 to 31? But again, it's just because it's where it happens to be in the circle. Next one on our list is matched filter. Here we have our same options as color range RGB. So let's go ahead and select a color. And you'll see, let's add a second one. Same sort of setup as the other color matching algorithms. We have our color swatch here. We can click on to bring up the editor. For match filter, as it has been in the past, we're actually selecting a threshold. And again, we have multiple colors now that we can support. So if we view the range, we see the colors from both of those. Next on our list is RX Anomaly. So for RX Anomaly, we set our image segments and sensitivity. This is the one algorithm where in the UI at least there aren't any changes, but behind the scenes there are. So there's 3 different color spaces we work with in ADIAT. There's RGB, which is what computers and cameras think in natively, using the term think loosely, but operate in natively. There's HSV, which is a little more intuitive and easier to understand because, again, it's that 360-degree view. And really what we're talking about when we talk color is usually hue, and then saturation and value are somewhat analogous to intensity. So we talked about hue, and especially in scenarios where we have varying light conditions, we just set the saturation and value to account for that of, hey, stuff is in direct sunlight and shadows, so it works really well for situations like that. The third one we operate in is called lab, and lab is really good in that it approximates human perception. So for anomaly detectors like RX Anomaly, and we'll see MR Map here in a moment, we have lab as either the default or an option because it is most close to how humans perceive things. So since we're looking for anomalies that align with how we see an image, we wanted the detector to work the same way. So all that being said, RX Anomaly has been switched from an RGB-based detection system or anomaly detection system to lab-based. As I mentioned, MR Maps. So for this one, we actually allow you to select the color space. Lab is the default. If you come in through the wizard, it'll set lab, but we went ahead and made it available to the user to make that selection should they choose to. The quantization process is a little different depending on which one you select, but it's transparent to the user. So again, it's more in here at this point just so you can see the difference. If you want to try using HSV or RGB instead of lab, you are more than welcome to do so, but lab is a really great place to start for this. Finally, we have our AI person detector. This one, no real changes that you see in the UI, but there's 2 huge changes behind the scene. One, GPU setup. If you were coming to us from ADIAT version 1.6, you probably went through the trials and tribulations of getting the AI library setup, which was dependent on CUDA libraries and all sorts of complexities. Thankfully, a new version of the detection libraries have been made available, and we don't need to go through those hoops anymore. So congratulations if you did that. If you haven't done it, you're in luck. You don't have to go through that process, especially on Windows, or specifically on Windows. The library will utilize whatever GPU you have. You don't have to have special drivers set up and special libraries set up. It does all that for you behind the scenes. Secondly, and I kind of touched on this a little bit, the AI person detector algorithm itself has been completely retrained for version 2.0 and includes images with much more diverse environments. So images from snow, both, meadows covered in snow, as well as more alpine snow environments, which makes it much more efficient in detecting people in those environments. So before, I didn't really know how to handle those scenarios because I wasn't used to seeing white backgrounds. That has changed now. It works really well in those environments as well because it has been specifically trained on image sets from those environments. Moving from our RGB algorithms over to our thermal algorithms. So we have two here still. We have temperature range, where you set your range, in temperature anomaly, where we set above below mean, anomaly threshold, which is how many standard deviations, and then image segmentation again. You will possibly note that we have removed one option from both of these. You used to be able to set the color map, and that has actually gone away because we're changing how we're storing the output images now. As you may recall, in previous versions of ADIAT, if you went to the output folder, we were storing duplicate copies of the images with the areas of interest highlighted in them, which is fine, except it takes up an incredible amount of room because you're storing a complete second copy of the image. Now we're storing what looks like a black image, but it's actually what's called a mask, and it actually contains just the dots, the individual pixels that represent the anomalies or areas of interest. And as you can see from the tooltip here, instead of 8-9 megabytes, we're storing 18 kilobytes. So much more efficient from a storage standpoint, and we're still able to get to the same place. If you do need the actual augmented images, we'll show you in the viewer how you can go ahead and export those and have those to do with whatever you need. You also see in here we're also storing some thumbnails now. Again, this is just to make the viewer experience more efficient. Rather than generating a lot of thumbnails on the fly, they're created and stored during the analysis process and just loaded in the viewer. With that, I think that's a good place to stop this first video. Thank you very much for being here, and we'll see you in the next one where we're going to click on View Results and take a look at the image viewer experience.